Hi, this video is about a tool that was invented by Isaac Newton to try to explain motion a little bit better, and that tool is called momentum. So let's see how he invented the idea of momentum here. He started with his second law of motion, F equals ma, and he used some previous knowledge about acceleration and substituted, instead of using acceleration, he used the final velocity minus the initial velocity over the time. And he did this on purpose because he realized that as you did some other things to this, let's say you multiplied both sides of the equation by time, that would get rid of it over here and move it to the left side of the equation, giving you this. And going a little bit further, if you were to distribute the mass by the final velocity and the initial velocity, just go ahead and multiply them, multiply the mass out and distribute it there, you would get to this expression. And this looks a lot more complicated than F equals ma, but Isaac Newton invented a new category for this mass times velocity. You see it two times, mass times final velocity, mass times initial velocity. He called this new quantity momentum. Mass times velocity, he said, was equal to P, which stood for momentum. That seems like a weird letter choice there, but we've already used m for mass, so we can't really use it for momentum as well. So instead we use P, and that's what we're going to use here. So he realized that this mv quantity here, if he called it momentum, instead of writing mv, he would just write P. And this had a lot of important uses, he found. And so the final expression, if we have the final momentum minus the initial momentum, this is really just the change in the momentum, how much it's increased by. And so, this expression, he found that the change in momentum of an object is equal to the force on that object multiplied by the time that the force is active. And so this idea is known as the impulse momentum theorem. We'll talk a little bit more about this theorem in a later video, but for today I want to just focus on this quantity momentum. So, what is momentum in physics? Well, as I said at the start of the video, it's a tool for explaining motion. A new tool. We've already used forces to talk about motion. Newton's second law says that an object will accelerate given a net force and its mass. But now we're going to use a new tool called momentum, and momentum is the product of mass and velocity. So here's that equation again. Momentum is also a vector quantity, so it has a direction. And momentum is often called inertia in motion, or in other words, mass in motion. So if something is moving, it's got momentum. You have to be moving in order to have momentum. So let's look at some examples of this. Let's say you have a football with a mass of 0.45 kilograms traveling east at a speed of 20.0 meters per second. What's the football's momentum? So mass, I write, is 0.45 kilograms. Velocity is 20 meters per second east, or in other words, positive 20 meters per second. What is the momentum? Using this equation, momentum is simply the mass times the velocity. So we'll multiply these two numbers together and we get a positive 9. And for the units for momentum, it's going to be kilograms right here multiplied by meters per second. And you might think that, okay, there's going to be there goes my other whiteboards. You might think that there's going to be a nice abbreviated unit for momentum, but no, this is it. So momentum is measured in units of kilograms times meters per second. There's no easier way to say it either. So that's what we're stuck with for our units. Let's look at one more example of momentum. And let's talk about one of the best animals that exist out there in the universe, and that is penguins. I love penguins. They're so cute. Let's say we have a 23 kilogram emperor penguin, and he swims at a speed of 1.50 meters per second. How fast would a 2.15 kilogram little blue penguin need to swim to have the same momentum? So we have a big penguin and a little penguin, and we want to know how fast does the little penguin have to swim in order to keep up with the momentum of the big penguin. So for the emperor penguin, the first thing we need to do is figure out how much momentum does the emperor penguin have. If it's got a mass of 23 kilograms and a velocity of 1.5 meters per second, momentum is mass times velocity. So we'll multiply the mass and velocity together, and the momentum of the emperor penguin is 34.5 kilograms times meters per second. Now, we're going to use that momentum here, and we're going to say that's going to be the momentum of the little blue penguin. We want to know how fast did that little blue penguin need to go to have that same amount of momentum. So for the little blue penguin, the mass is 2.15 kilograms, much less than 23. We don't know the velocity, but we do know that we're going to use this momentum over here as our momentum for the little blue penguin. So that's 34.5 kilograms times meters per second. Momentum is mass times velocity, but in this case, we're going to be solving for velocity here. So we need to get rid of whatever is next to it and do some algebra. So we need to undo the multiplication right here. We're going to divide by mass, and so that will undo the mass multiplication on this side. That leaves us with momentum over mass for the velocity, momentum over mass. So when we do that calculation, 34.5 divided by 2.15, and we get an answer of 16.0. And if you look at our units here, we have kilograms times meters per second divided by kilograms. These kilograms will just cancel out, leaving us with meters per second for our answer. So that's all I've got for you in this video. Remember, a bad attitude is like a flat tire. You won't get anywhere until you change it.